I apologize for that. The issue was that some of the file was looking at one folder for differentiation, and the rest of my files were in a different folder for integration. So I couldn't get my single MLX file to run until I moved all my files together. So that being said, let me just separate and look at the refinement table in a separate .mlx file for just a moment. And these warnings to the right, this is what I was expecting could go wrong. Okay. So what we may have to do then is think about changing the values of n to be multiples of 6. So let's do that. Okay, and this way all of our values will be able to run. In fact, I'd still like to do doubling. So let's do 6, 12, and let's double that to 24, and we'll double this to 48. There we go. Now all of our files, all of our methods will be able to run without any warnings of this sort. The Simpson's 3/8 rule was the one complaining. Okay. So if I run this, I can now display my errors. Okay. And here's the errors for the trap rule. If I hit a prime here, that'll display them a little bit nicer in a vertical fashion. And then here, let's take a look at the errors from the various rules. And let's get them in order. Simpson's rule, and then the Simpson's 3/8 rule. Yeah, and that's already sort of interesting, I think. We get that the errors are 0 for the Simpsons rule and for the Simpsons 3/8 rule. Now what's going on here? Well, recall that Simpsons rule and Simpsons 3/8 rule are accurate for polynomials of high degree. That's something we very briefly mentioned in class. Here, let's make this a little more challenging then. Okay. Let's make this an 8th order polynomial, and I'll rescale it so that the integral is still equal to 1. Okay. There, and now we've got different various errors. The trap rule in the first column, second column is Simpson's rule, third column is Simpson's 3/8 rule. And then let's also display, and this will be the rates. Okay. And there's one little issue, just namely that I'm getting negatives, but let me just put minus signs in front of my formulas then. That's just a correction to the formula. Okay. And comment this out for a moment. Let's just look at the rates. And there, this is interesting, I think. So we predict that the trap rule should be second order accurate, and what do we see for these rates? We see 1.98, 1.99, 1.999. Okay, it's very close to 2. In the remaining rules, we thought they were fourth order accurate, and sure enough, the numerically computed rates are fairly close to that. Okay, so as far as the assignment goes, I would just like you to organize this into a table like we have in the past, and that's how we do refinement tables.